This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 1 of Week 3. Conduction Fundamentals. Fourier's law of conduction, thermal conductivity, and steady-state heat flow through a plane wall. One law for every conduction problem on the exam, Fourier's law. Everything else is bookkeeping. You need three things: a material property, K, the thermal conductivity; a geometry, the area perpendicular to heat flow and the wall thickness; and a driving temperature difference across the wall. Get those three numbers, and the answer reads off in one line. Same three-column shape as Week 1 and Week 2. Quantity, symbol, units, source. Inputs up top: K, area, wall thickness. Then the two face temperatures. Bottom row is Q dot, what you solve for. One note: for a temperature difference, Kelvin and Celsius are interchangeable. For an absolute temperature, like in radiation, they are not. Fourier's law in one dimension. Q dot equals minus K times A times dt over dx. K is the conductivity, A is the area perpendicular to heat flow, and dt over dx is the temperature gradient. The minus sign is convention. Heat flows down the gradient, hot to cold. Divide by area, and you get the heat flux, Q double prime. For a flat slab with constant K and fixed surface temperatures, Fourier's law integrates to a clean closed form. Q dot equals Ka delta T over L, where L is the wall thickness. Three assumptions are baked in: one-dimensional flow, steady state, no internal heat generation, adequate for almost every plane wall problem on the PE. Thermal conductivity is a material property. It spans 4 orders of magnitude. Pure metals, copper, aluminum, silver, sit at the top, because conduction electrons carry energy efficiently. Alloys like steel are an order lower, brick and concrete lower still, insulation lower again, and air is the floor. That spread is exactly why insulation works. And worth flagging, many of these values are tabulated in Chapter 9 of the Handbook. Building materials, insulation, soils, and rocks. For anything not listed, the problem statement gives you the value. K does vary with temperature, but mildly over exam ranges. Usually under 10% across a 100 Kelvin span. Bottom line for the PE: if the problem gives one value of K, use it. If it gives two, evaluate at the mean wall temperature, the average of the two faces. Worked problem. A solid brick wall, 4 meters by 2.5, 100 millimeters thick, K of 0.72. Steady winter conditions hold the inside face at 22 Celsius, the outside at 5. Ignore surface convection and radiation for now. Find the steady-state heat loss rate. Apply the plane wall form. Q dot equals Ka delta T over L. Drop in the table values, minding the millimeter to meter conversion on the thickness, and Q dot lands on about 1224 watts. Sanity check it. 1200 watts through 10 square meters of bare brick is about one space heater running continuously. Plausible for an uninsulated wall. That's roughly 4180 BTU per hour. And the sign is positive inside to outside, exactly as drawn. 5 traps that quietly cost points. 1. Mixing units. Convert all lengths to meters or feet before you substitute. 2. Confusing rate with flux. Q dot is total watts. Q double prime is per unit area. Read the question. 3. Kelvin versus Celsius. Equivalent for a difference, not for an absolute temperature. 4. Wrong cross-section. Area must be perpendicular to heat flow. 5. Forgetting steady state. The plane wall formula fails while the wall is still warming or cooling. That's transient conduction. Topic 4. Bookmark the page. Fourier's law, the plane wall form, and thermal diffusivity. Everything you need for conduction. All live on one printed page. Fold the corner. Up next, Topic 2. Thermal resistance networks. We recast Fourier's law as heat flow through a resistance, the move that lets you stack composite walls in series, like electrical resistors.
The full study guide with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.